This is CS50 and today we'll be covering Big O notation. Now Big O notation just describes how an algorithm performs as it scales, meaning as it deals with larger data sets. So it doesn't give the exact runtime in minutes or in seconds, but it just gives you a sense of how it performs as we deal with larger amounts of data. So up here on the board I have 6 of the most common algorithm runtimes. For example, O of 1. Let's say we want to search through this list. We just want to return the first element of this list. No matter whether or not this list was 1 billion entries or only 5 entries, this would always return O of 1 because we only have to search at the first index. Now, let's do O of n. Let's say we want to search this list for the number 7. So we searched this list and we found out that number 7 is indeed in the list. But to do that, we had to search through the whole list to prove that 7 was in the list. So therefore, this is O of n. Now for O of n squared, let's say we want to generate all possible pairs of this list. So for example, 1, 1, 1, 2, 1, 3. The reason it's O of n squared is because not only do we have to iterate through the list once, but for every single element, we have to iterate through the list again to generate these pairs. So therefore, this is O of n squared. Now, for O of x to the n, let's say we have a 3-character password, and the password was cat. We have to, and we're assuming that it's only A to Z, we have to guess all 26 characters first, and all 26 characters times all 26 characters from AA to ZZ. And that's still not cat, so we still have to guess from AA to ZZZ. And as you can see, in this case, it would be 26 to the third, because we have to guess 26 different possible guesses for our password. Now for O of log n, let's say we want to generate every possible permutation of this list. This would become O of n because first, okay, so this is 5. Now we have to generate, there's 4 different possibilities to arrange this list, and then there's 3, and it keeps on getting smaller. But if this was 1 billion, this would take an obscenely large amount of time to fulfill. Now for O of log n, the general idea of this is you want to split a problem into smaller pieces. So for example, let's say we want to search for the number 2. So first we would check the middle entry, it's 3. Now this is sorted, so this helps us in our binary search algorithm. So we want to search for 2, we start at the middle, it's 3. Is 2 less than 3? Yes. And because of that, we know that we can discount these because we know 2 can't possibly be there. Now we check this one, we check the middle, is 2 equal to 2? Yes. Now we return true, and we completed our algorithm. So for some tips and tricks, first, dominating terms matter. If your algorithm has a runtime of n plus log n won't matter much because let's say the number 1 billion pops up. This would be only 9, while n will be 1 billion. And you can obviously see that n will be the one that's holding this algorithm back from performing as optimally as possible. Next, if segments add. So for example, let's say we're doing bubble sort and binary search. So first we're sorting the algorithm, we're sorting the list, and then we're searching the list. This is when your algorithm, when you add each segment. But remember, in terms of dominating terms, it's still n squared. And if it's repeating itself, you multiply. And this stems from the idea of this O of n squared, which is really a polynomial algorithm, because not only do you have to iterate through this again, you have to iterate for each element. But let's say if you want to generate every possible third permutation, then you would have to do a first element, then every element again, and then every element again. So this has been Big O notation. Hope you have a great day, and this was CS50.